All right, so what we're going to do now is we're going to start stoichiometry. Now, none of this will be on the test, which is again next Friday. Okay, the next Friday the test will again all be online. You guys will be here in class again, but the other people will be at home taking it. And so it'll probably end up being like an open note again on that test, because it's not fair for you guys to be here monitored and the people at home to have access, you know, even though technically we're on the honor system. Don't want to put people in a situation that they're uncomfortable with or, you know, conflicted with. So we'll just make it open note on this one, and hopefully this will be the last one, because then we're gonna come back, everybody's gonna be here 5 days a week, and then we'll just do a traditional, everybody takes it in class type test. And there'll be the few virtual kids that will still take it online, but they'll take it at the same time you guys do, you know, and have the same time period as you do, okay? And so most of my tests take most of the time, so you won't really have time to be looking stuff up. You're gonna need to know how to do it without looking it up. If you have to look it up, you're gonna run out of time. All right, but stoichiometry, somebody tell me, what is stoichiometry? What would you say a definition? We did it a lot last year, or 2 years ago. How many seniors? Do we have any seniors in here? This side, okay. So you guys took it 2 years ago, so it might be a little rusty, okay? But what do we remember about stoichiometry?
It was easy.
It was easy, okay? That's good. What else? What is it?
Math.
It's math, right? Basically it's math to find what? It's grams to moles to grams. It's finding grams of a given amount of reactant, how many grams of the product are going to get formed. Or if I have so many grams of this reactant, how many grams of the other reactant do I need to react with it fully? It's the study of mass relationships in a chemical reaction. The study of mass relationship. In a chemical reaction. And RXN, by the way, is always my abbreviation for reaction. Okay? So, I have a reaction that says that silver nitrate is going to react with some calcium chloride. Okay? Now, this is first off, what type of reaction would this be? Double replacement, good, okay? And I know that because it's a compound and a compound. Two ionic compounds, double replacement means they're just gonna swap, right? Every compound has two things, a positive thing and a negative thing. Okay, it doesn't matter how big or complicated the compound is, it's gonna have a positive thing and a negative thing. If it's real complicated, you're gonna have polyatomic ions. So in this case, silver is the positive thing, nitrate is the negative thing. Calcium is the positive thing, chloride is the negative thing. Okay? So what are we gonna make?
Silver chloride.
Silver chloride, and we balance the charge, silver. Now you may not know it, you have to know it, but eventually you'll learn it. But silver, the little black number above the symbol, did I give you a periodic table?
Yeah.
Okay, so if you're looking at that periodic table, that 1 is its charge, its oxidation state, okay? Now it's also in group 1B or group 11, and that's gonna tell me that it's gonna be +1 as well, okay? So silver's +1, chloride is -1, so what's the formula? Just AgCl. Even though it's a 2 here, we don't carry the 2, we balance just the oxidation numbers, okay? Plus what? Calcium And the calcium is an alkaline earth metal in family 2A, or family 2. So what's its charge gonna be? Plus 2, okay? Or 2 plus, okay? And then nitrate is a polyatomic ion, that's -1. So I need 2 nitrates, right? So how do I do 2 nitrates? Parentheses and a 2. Okay? Now, we're gonna learn solubility rules, but we're gonna learn the big 3 solubility rules, that all alkaline metals are soluble. Anything in column 1. Any compound with sodium in it dissolves in water. There's no precipitate ever with anything from the alkaline metals. They're always soluble. Okay? All nitrates are always soluble. And all ammonium compounds, the NH4 plus up at the top, they're always soluble. That's the only 3 things that you have to memorize for solubility. All alkaline metals are always soluble. All nitrates, always soluble, and all ammonium. So since this is a nitrate, I know it's aqueous, because it's gotta be soluble. And if a reaction is gonna occur, this must be a precipitate that's gonna form. Now what else do I need to do to this equation? Balance it. 1 silver, 1 nitrate, but I have 2 nitrates. So I have to come and put a 2 here, but that gives me 2 silvers, but that gives me 2 chlorines, and looky there, my golly, I have 2 chlorines. Okay? All right? So that's not too bad, but that's not stoichiometry yet. That's just the first step of a stoichiometry problem, is writing a balanced equation. Okay? Most of the time on an AP test, the balanced equation is given to you. Okay? I don't always do that. But again, we're gonna learn about writing balancing equations and the naming kind of as we go through. We're not gonna spend a whole section doing it. We're just gonna, as we do stoichiometry, do this. This is us learning and refreshing how to write balanced equations. All right, but stoichiometry says that if I have 15 grams of silver nitrate, how many grams of calcium chloride do I need to react with it? Well, what's our balanced equation tell us? It's a what ratio? Mole ratio, right? This tells me that 2 moles of silver nitrate are going to react with only 1 mole of calcium chloride. Now the moles weigh different amounts because these have different molar masses. So we have grams, so it's not going to be twice as many grams. So we can't just say 7.5 grams here, because it's a mole ratio, not a gram ratio. So stoichiometry is always going to go mass of the given to moles of the given to moles of the unknown. That's what you're looking for. To the mass of the unknown. So how do we convert grams to moles? What do we use? What's the conversion factor? The molar mass of the given. Okay? So we're going to use the molar mass of the given, which we've already kind of done a couple of problems with those, changing grams to moles. So how do I go moles back to grams? Over here at the end, moles to grams.
Molar mass.
The molar mass again, but this time of which one? The unknown. Okay? So how do we go from moles to moles then? The ratio, that's the 1 to 2. That's your coefficients. That's the only time you're going to use these coefficients, because molar mass is always per 1 mole. Always 1 mole. So this is going to be, my fancy word I like to say is the stoichiometric factors. Okay? Coefficients of the balanced equation. Okay? The mole ratio. Coefficients from balanced equation. It's mole ratio. And the mole ratio, because we always want the unknown on the top and we need the known to cancel, it's always going to be unknown over known. Now units will tell us that, but it's always unknown goes on top. The known's going to cancel out. So this is going to be our format. Now, you may be given mass and have to stop at moles. You may be given moles and have to go to mass. You may just be given moles and ask for moles. Okay, so we need to always just, where am I starting and where am I ending? What am I given? What am I looking for? That's the keys to solving any problem. Okay, so let's just solve this problem. Am I on the video over here? Okay. So if I go, I'm going to start with my given 15 grams of silver nitrate. Okay. I need to convert that now to moles. So I'm going to use the molar mass of the given, the silver nitrate. 107.9 plus 14.01 plus 48 all comes out to 169.81 grams over 1 mole. Now, did I do that right? I didn't do this on purpose, but did I do it right? Why? Grams have to go on the bottom here to cancel, okay? It's Friday afternoon, well, I wish it was Friday afternoon. It's Friday. It is 107.9 or 107.8? 107.9. So it's going to be 0.91, okay, grams. Okay, so if I stop right there, what do I find? Moles of silver nitrate. So now I need to go to moles of the thing I'm looking for, calcium chloride. So what's my ratio? 1 over 2. And go ahead and say 1 over 1 mole of calcium chloride for every 2 moles silver nitrate. So now moles of silver nitrate are canceled. So if I stopped right there, what would I find? Moles of calcium chloride. Okay? And then how do I go then to grams? The molar mass of the unknown, the calcium chloride, is 35.45 times 2 is going to equal 70.9 plus 40. We'll say 40.1, make it come out easier. So 111 grams. So now I'm left with grams of calcium chloride, which is what the question's asking for, so I know that I'm finished. Okay? So if it's on the top, you multiply, on the bottom you divide. You don't have to put this into your calculator a bunch of times. You just say 15 divided by 169.91 divided by 2 times 111 equals 4.90. Okay? So 4.90 grams of calcium chloride. What does that mean? What did I just find?
That's how much you need to react with the 15 grams.
Okay? If I have 15 grams of silver nitrate, I only need 4.9 grams of calcium chloride to react with it. Okay? And that's going to be, so we would not have a limiting reactant here. They're both going to get used up completely. That's the exact amounts we need to do. But it's a balanced equation only gives us a mole ratio, not a gram ratio. Okay? So, stoichiometry is just super easy. Now, what would happen if I put 15 grams of calcium chloride in there with 15 grams of silver nitrate? Okay? So, Ray, what?
You'd have excess calcium chloride.
How much excess? 11.1, right? 15 minus the 4.9. Only 4.9 are going to react. The other is just going to stay in the solution. It's going to be excess. So when the reacts, if I put 15 and 15, this is going to be a solid. It's going to precipitate out. Go to the bottom. We could filter it. This is gonna be in solution, so in my beaker, in my test tube, wherever I'm doing this reaction, all of this is gonna get used up. There won't be any of that left. I'm gonna have, what do we say, 10.1 grams of this remaining, okay? That's still gonna be floating around in the solution. This is gonna be settled to the bottom or filtered out, and this is still gonna be floating around in the solution. Now, how would I go and find this? What would I do to find the calcium nitrate?
Same thing.
Same thing, except now my unknown is this. So if I went through, the steps are gonna be the same. 15 grams divided by this, and instead of saying 1 mole of calcium chloride, I'm gonna say 1 mole of calcium nitrate. And then I'm gonna have to multiply by the molar mass of the calcium nitrate, which 48 and 14 is 62. 62 times 2 is 124. 124 and 40 is equal to 164.1. And this pen is not worth anything. Okay? So 164.1. So that is just give us the amount of calcium nitrate that was also produced in the chemical reaction. So we can find how many reactants there are, we can find out how many products there are, you know, we could, this could be my given and this be my unknown. You need all 4 things in the balanced equation, but you're always just gonna be looking for one given, one unknown. Okay, so hopefully this is something that you remember and it's something that you consider to be easy. All right? Have it, give me a stop.